Hello everyone. In this video, let us discuss some of the numerical problems on sedimentation tank. In a previous session, we discussed about various things associated with the sedimentation tank. That is, what is the sedimentation tank, various definitions associated with the sedimentation tank, and also we understood various types of the sedimentation tank. Now it is time to discuss some of the numerical problems. That is, we are doing the problems on design of the sedimentation tank and also few problems on understanding the detention time and also the velocity of the flow, and also we solve some of the problems on finding the settling velocity of the particles. So let us start with the problems. Let us check the first numerical. So whenever you will be following the class, kindly solve the problem along with me, then it will be easy to understand. Let us take up the first problem. The problem goes as it is. The maximum daily demand at a water purification plant has been estimated as 12 million liters per day. This is one of the major data they have given. Next is the design the dimensions of a suitable sedimentation tank fitted with mechanical sludge removal arrangements for the raw supplies, assuming a detention period of 6 hours and the velocity of flow as 20 centimeters per minute. This is the data given. Let us just pick out what are the data that are available in order to find out the dimension. What actually they are asking for us is the dimension of the sedimentation tank. This is the ultimate thing we need to find out. Dimension of the sedimentation tank. So in order to find this, what are all the data that has been given data? First one is the maximum daily demand. Maximum daily demand that is arriving to the water purification plant, that is the maximum amount of the water that is appearing daily. They have given it as 12 MLD, which means million liters per day. What is the next data they have given to us? They have given the detention period. Okay, detention period they have given it as 6 hours. This is one more data they have given, and also they have given us the velocity of flow. This one we can call it as V. Velocity of flow they have given it as 20 centimeters per minute. Now these are all the data that are available. By making use of these data, we need to find out the suitable dimension for the sedimentation tank. Here we can see the given data. By making use of this data, now we need to find out the suitable dimension for the sedimentation tank. First, let us understand the quantity of water to be treated in 24 hours. So they have given us the data, that is maximum daily demand per day is 12 million liters, which means the quantity of water to be treated in 24 hours. In 24 hours, it is clearly mentioned as 12 into 10 raised to 6 liters. Is it? So for million we have written as 10 raised to 6. So if this is the quantity of the water that is treated during 24 hours, then what will be the amount of water that is treated just during the detention period of 6 hours? So next is the quantity of water treated during detention period of 6 hours. In order to find that, we just follow the simple method of cross multiplication. See, in 24 hours, water treated is 12 into 10 raised to 6 liters. So then, in 6 hours, what is the amount of water that is treated? In order to find that, we just cross multiply the things and then we will be finding the answer. Just I will be substituting the same here. 12 into 10 raised to 6. Okay, and then multiplied by 6 divided by 24. Okay, so what will be the unit left? Here it is hour, here it is hour, both of them gets cancelled. The remaining unit will be liters. So answer is supposed to be 3 into 10 raised to 6 liters. So let us convert it into meter cube. We will be dividing the answer by 10 raised to 3. Then the remaining answer will be 3 into 10 raised to 3. 3000 cubic meter. Okay, so 3000 cubic meter is the capacity for which we need to design the dimension of the tank. That is, the capacity of the tank required is equal to 3000 cubic meter. So for this capacity, now we need to design the sedimentation tank. So by making use of the previous data, what we found, so capacity we got it as 3000 cubic meter. This was the answer we got. Now let us find out the length. Before finding out the length, let us check the velocity of a flow is given as 20 centimeters per minute. Okay, let us convert it into meters. That comes to be 0.2 meters per minute. So length of the tank is equal to velocity of flow into detention period. Okay, so here we can see velocity of a flow, we have it as 0.2 meters per minute into detention period is 6 hours. So it is given in hours. Let us convert it into minutes. That is 6 into 60. So then it will be in minutes. Minutes. After we multiply both of them, the answer is supposed to be 72 meter. This is the required length of the tank. Now let us find the cross-sectional area. Since already we got two of the data, one is the capacity and the length, we can just find out the capacity divided by length, then we will be getting the cross-sectional area of the tank. Let us write it. Cross-sectional area of the tank, which is equal to capacity divided by length. We have got capacity as 3000 divided by, this is in meter cube, this is in 72 meters. These two gets cancelled and we get the answer as meter square, or we can write it as 41.7 meter square nearly. So this is the cross-sectional area of the tank. So now let us assume water depth in the tank. Let us assume the water depth in the tank as 4 meter. So since we have the depth here, we can find out the width by making use of the cross-sectional area. Since we have got cross-sectional area as 41.7. So now the width of the tank. Width of the tank is equal to cross-sectional area divided by the depth. So we can get it as 41.7 divided by 4. We get the answer as 10.42 meter. Nearly we can write it as 10.5 meter. This is the width that is required for the tank. Now we got almost all the dimensions, that is length of the tank, width of the tank, and also the depth of the tank. But this is the depth which is given only for the water. So for overall depth, we need to consider freeboard plus water depth. Okay, so we know the meaning of the freeboard, that is the extra provision we give it in the tank. If suppose this is the capacity that I require, this one I say it as the water depth, some extra provision is given for the tank in order to control the overflow and all. So that is the freeboard. Let us consider it as 0.5 meter, and as usual already we assumed the water depth as 4 meter. So the overall depth becomes 4.5 meter. So we got all the dimensions that are required for the tank. Here are the dimensions. One is the length of the tank, and then the width of the tank, and also the depth of the tank. So here we can write the overall dimension of tank. So overall dimension of tank, length into breadth into depth. So 72 meter into the width was 10.5 meter into The depth is 4.5 meter. This is the required overall dimension of the sedimentation tank. Now let us take up the second numerical on the design of the sedimentation tank. The problem is 2 million liters of water per day is passing through a sedimentation tank which is 6 meter wide, 15 meter long and having a water depth of 3 meter. See, in this case they are saying 2 million liters per day of water is passing through the sedimentation tank, and also they have set the dimension of the tank as 6 meter wide, okay, 15 meter long and water depth is 3 meter. 3 meter is the water depth. So first thing they are asking to find out, these are the given data, okay. So next they are asking us to find out, first one is find the detention time for the tank. Here they have not given us the detention time, we need to find out the detention period or detention time required. Next is, what is the average flow velocity through the tank? They are asking us to find out the flow velocity V. Next thing is, if 60 ppm is the concentration of suspended solids present in turbid raw water, how much dry solids will be deposited per day in the tank, assuming 70% removal in the basin and average specific gravity of the deposit as 2. So these data we will separate them when we will be solving this third point. The last thing they are asking us to find out is compute the overall overflow rate. So third thing is related with the dry solids, amount of dry solids we need to find out, and the fourth one is they are asking us the overflow rate. These are the things we need to find out by making use of these data that has been given to us. For finding the detention period, first let us find out the capacity of the tank by making use of the given data. Capacity of tank is equal to, just multiply all three dimensions, 6 into 15 into 3, which is supposed to be 270 metric cube. So this is the overall capacity for which we need to get the design period. We have a formula, that is detention time is equal to capacity divided by discharge. Okay, so here capacity will be in meter cube and discharge we need to substitute in meter cube per hour, so that meter cube gets cancelled and answer comes in a hour. In order to do so, already we have got the capacity, that is capacity we have got it as 270 meter cube. Let us keep it aside, and now let us find and convert the discharge of the water, that is given as, discharge is given as 2 into 10 raised to 6 liters per day. Okay, so let us make it 2 into 10 raised to 6 divided by 24 hours, then it comes for liters per hour. So liters per hour, it is supposed to be 83.33 into 10 raised to 3 liters per hour. So let us convert it into meter cube per hour, divide it by 10 raised to 3. So it becomes 83.33 meter cube per, since we have divided by 10 raised to 3, so it gets converted into meter cube per hour. So we will be substituting the same value in this formula. Let us substitute. We have the capacity as 270 meter cube divided by the discharge is 83.33 meter cube per hour as 3.24 hours. This is the required detention period for the tank. The second thing is we need to find out the average velocity of the flow. That is average velocity of flow. In order to find the average velocity of a flow, we have a formula, discharge divided by cross sectional area in terms of the breadth into depth. So we have the discharge as 83.33 divided by, so this was discharge in terms of meter cube per hour. So this is cross sectional area, that is 6 into 3. Okay, we can get some answer. Before moving on to that, here is the unit is 6 into 3 meters square. So the supposed unit will be meter per hour, but we want answer in terms of centimeters per minute. In order to convert it, let us convert meters into centimeters, multiply it by 100, and also to convert hour into minutes, divided by 60. Answer is supposed to be 7.72 centimeters per minute. This is the required average flow velocity. The third thing, in order to find out the mass of suspended solids deposited in the tank, let us check from the steps. First we have the quantity of water passing per day is 2 into 10 raised to 6 liters, which was given as 2 mld. The same thing we have written as 2 into 10 raised to 6 liters. And then they have given it as concentration of suspended solids is 60 ppm. Here we have some data. For 1 ppm, we can convert it into 0.001 ml per liter. The same thing for 60 ppm concentration, we have it as 0.06 ml per liter. Next, let us check the quantity of suspended solids entering the tank. Quantity of suspended solids entering the tank. So why we are taking it in this way is, if we are saying 60 ppm is the concentration, which means 0.06 ml per liter of suspended solids is getting entered into the tank. So if this is the total quantity of the water, what will be the total amount of suspended solids that is getting entered into the tank? In order to find that, so just we are multiplying both of them, that is quantity of the water passing, that is 2 into 10 raised to 6 liters. Here we have 60 ppm, but we can't write it as ppm because unit is differing. So in order to convert it, that is why we are using this one, which is 0.06 ml per liter. Okay, so this liter gets cancelled. The answer is supposed to be 12 into 0000. Yes, what is left? Ml. So this is the answer left. If you divide it by 1000, so the answer is supposed to be 120 liters. Okay, let us divide it by 10 raised to 3 or 1000 again. So we will be getting it as 0.12 meter cube. So this is the amount of suspended solids or quantity of suspended solids that is entering the tank. So now let us find out mass of suspended solids deposited per day with 70% removal. Here we have the data for the density. There we said the quantity of the suspended solids deposited in the tank per day was 0.12 meter cube. Apart from that, we are able to consider only 70% of it. Let us multiply it as 0.7. So this is in meter cube, and we have the density as 2000 kg per meter cube. So meter cube gets cancelled. Answer is supposed to be 168 kg. So mass of suspended solids deposited per day, even if you are removing 70% of the solids, then it is 168 kg. This is the answer for the third case what they have asked. Next thing they have asked is the overflow rate. The last one they are asking is the overflow rate. Overflow rate can be defined as the discharge per unit plan area. So the discharge is Q and the plan area is B into L, and the unit for overflow rate is supposed to be liters per hour per meter square. So let us this one is already in meter square. Thus let us substitute this in terms of the liters per hour. This was 83.33 into 10 raised to 3 liters per hour. Okay, divided by, this was breadth was 6 into length was 15. So this is in meters square. Answer is supposed to be 926 liters per hour per meter square. So this is the required overflow rate per hour for this much meter square area, for 1 meter square area. So 926 liters of water gets overflowed. Let us take up the third numerical. It is a rectangular settling tank without mechanical equipment is to treat 1.8 million liters per day of raw water. The sedimentation period is to be 4 hours. So here in this case they have given sedimentation period is 4 hours. The velocity of flow is 8 centimeters per minute and the depth of the water and the sediment is 4.2 meter. If an allowance of 1.2 meter for sediment is made, what should be the length of the basin and also the width of the basin? They are asking us to find out the length of the basin and also the width of the basin. In order to find this, they have given us several data. Supply of the water to be treated. Supply of the water to be treated in 24 hours is 1.8 into 10 raised to 6 liters. So, what is the amount of water or water to be treated? Quantity of water to be treated during detention period. So, if in 24 hours 1.8 into 10 raised to 6 liters is treated, what if in the detention time of 4 hours? So in order to find this, just like in the previous case, we are just cross multiplying the answer, that is 1.8 into 10 raised to 6 liters into 4 hours divided by 24 hours. 0.3 into 10 raised to 6 hours. This is the 0.3 into 10 raised to 6 liters. Here hour gets cancelled, the remaining answer is in liters. So even though if we are converting it into meter cube, it is supposed to be dividing it by 1000, we get it as 300 meter cube or else cubic meter. This is the quantity of water we need to treat it during the detention period. So for this purpose, this is the capacity for which we need to design the tank. So in the problem, flow velocity is given as 8 centimeters per minute. In order to find the length of the tank, we have length is equal to velocity into detention time or detention period. Velocity is given as 8 centimeters per minute and we have detention time as 4 hours. So in order to convert 4 hours into minutes, we can multiply it by 60. So this becomes in minutes. We get it as 1920 centimeters. So which is supposed to be 19.2 meters. This is the required length of the tank. So now since we have the data for capacity and the length, we can find the cross-sectional area of the tank. So let us substitute the capacity, we have got it as 300 meter cube and length we have got it as 19.2 meter. So we get it around 15.6 meter square is the cross-sectional area for the tank. In the question they have given the data as depth of sediment plus water, which is supposed to be 4.2 meter. Since they have given it as 4.2 meter, now let us check only if we are considering the depth of the sediment. Okay, so for depth of the sediment we have it as 1.2 meter and for depth of the water we have it as 3 meter. So in order to find out the width of the tank, just we can consider only the water depth. That is why since we have the data for the cross sectional area, and also the water depth. We can now find out the width of the tank required. Width of the tank is equal to the cross sectional area divided by the water depth. Cross sectional area divided by water depth. For cross sectional area we have it as 15.6 meters square, and the water depth we are taking it as 3 meters, and answer is supposed to be 5.21 meters. This is the required width of the tank. The next numerical is on circular sedimentation tank. Previous to this, the problems what we did are mainly on a rectangular sedimentation tank, and now we are taking up the circular sedimentation tank. Let us check the problem. A circular sedimentation tank fitted with standard mechanical sludge removal equipment is to handle 3.5 million liters per day of raw water. This is the one main data, that is 3.5 million liters per day of raw water. If the detention period, okay, this is the quantity of water, and detention period they have given it as 5 hours, okay, and the depth of the tank they have given depth as 3 meter. What should be the suitable diameter of the tank? This is the question. So in case of the rectangular tank, we will be having the length, breadth and the depth. Here, since it is a circular sedimentation tank, they are asking us the dimension in terms of the diameter. So then if we are finding the diameter, then we can easily design the tank. So let us check out with the problem. So by making use of the data that is given in the question, we have the quantity of water treated in 24 hours. So we have it as 3.5 into 10 raised to 6 liters. Okay. So if this is the amount that is treated in 24 hours, then what is the quantity of water that is treated during the detention period? In order to calculate that, we have 3.5 into 10 raised to 6 into the detention period is given as 5 hours divided by 24 hours. Just like in the previous case what we did, here hour gets cancelled, and the remaining, and the answer is 728 into 10 raised to 3 liters. If you are dividing it again by 10 raised to 3, the final answer is 728 meter cube. This is the capacity for which we need to design the tank. To find out the diameter, in order to find out the diameter, we have one standard formula. This formula can also be used to find out the volume. See here, the formula goes, volume is equal to d square into 0.011 d plus 0.785 h. This problem can be adopted when diameter is d and depth is h. So when volume is not available, we can make use of this formula in order to find out the volume. Here in this case, volume is available and also the depth is available. So depth we have it as 3 meter and volume we have it as 728 meter cube. Now we need to find out the D. Let us substitute the available data. Volume is 728 meter cube. Diameter we don't know, let us keep it as it is 0.011, and D keep it as it is 0.785 into this depth is 3 meter. So we are solving this by the trial and error. We will be getting the answer as D is equal to 17.3 meters. D is equal to 17.3 meters. This is the required diameter of the circular tank. Let us take up the fifth numerical. In a continuous flow settling tank, 3 meter deep and 60 meter long, what flow velocity of water would you recommend for effective removal of 0.025 mm of particles at 25 degrees Celsius? The specific gravity of the particles is 2.65 and the kinematic velocity for water may be taken as 0.01 centimeter square per second. These are all the data that are available. First we need to find out the settling velocity, and then we can find out the regular flow velocity. Let us check up the problem. So now in order to find out the settling velocity for the particle dia which is less than 0.1 mm, In the given problem, the diameter of the particle is 0.025 mm. So we can take up this formula Vs is equal to G divided by 18 into capital G minus 1 into d square by V. Let us check up for the substitution of these terms. G is actually the gravitational acceleration constant, which is supposed to be 9.81 meters per second square. Here in this data, we will be substituting all the data in terms of the centimeters. That is why I am converting this into centimeters, which on conversion becomes 981 centimeters per second square. Next is G, that is specific gravity of the particles, that is 2.65, which is already given in the question, and D is for the diameter of the particle, which is 0.025 mm, which on conversion to the centimeter, which becomes 0.0025 centimeters, and the velocity we have it as 0.01 centimeter square per second. Let us substitute all the data and find out what answer comes for the settling velocity. Let us substitute. Small g is 981 and 18 remains as it is. Capital G we have it as 2.65 minus 1. D square is 0.0025 whole square divided by V is 0. Velocity answer is supposed to be 0.0562 centimeters per second. This is the required settling velocity. Let us make use of the formula V by Vs is equal to L by H. So we want the value of V. So let us take Vs on the other side, Vs into L by H. So in order to substitute into this, we have all the data. Settling velocity previously we have calculated. L by H. L is length of the tank, we have it as 60 meter, and for the H, depth which is given as overall depth is 3 meter, but we have to give some provision for the freeboard. So if we are excluding 0.5 meter from this, let us consider 2.5 meter as the depth for which we are going to design the velocity. So if we are considering this, in order to calculate the flow velocity, we have settling velocity is 0.0562 centimeters per second into the length is 60 meter divided by the depth that we are considering is 2.5. So this is in meters and this is in meters, they gets cancelled. The remaining answer has to come in centimeters per second, because this is already in centimeters per second. Answer is supposed to be 1.35 centimeters per second. This is the required flow velocity if the settling velocity is this much. So after finding the settling velocity and the flow velocity, next thing we are finding is the velocity in order to check the score of the deposited particles. Here we will be finding the value for the score velocity. So what happens, what is the need of finding the score velocity? Whenever we find this value, if the velocity of the flow exceeds the value that comes with the Vd, so then the particles will rupture the material or the score the material, that is the scratches that will be found inside the pipe, that is actually the scoring action of the material. If the velocity is beyond the scoring velocity, then materials will be deteriorated. That is why we have to check that the velocity of the flow what we are fixing is within the limit of this scoring velocity. Now let us substitute the values and check out how much is coming for the scoring velocity. So we have this formula in order to find out the scoring velocity. So in order to substitute into this, we have again G, that is the gravitational acceleration constant, we have it as 981 centimeters per second square. Here we have a term, two new terms are that beta value we have to take it 0.04 if it is a granular sand material, we have to take it as 0.06 if it is non-uniform sticky material. In most of the problems they will be giving it as granular sand, that is 0.04. So it may be given in the problems, or sometimes we have to remember this value. We will be considering 0.04 in this case. Next, F dash is Darcy-Weisbach friction factor. We have the value as 0.025 to 0.03. Here we will be going for the higher value for the friction factor. So let us substitute all the data into the formula. Let us take it 8 into beta value is 0.04 divided by friction factor is 0.03 into 981 centimeters per second square. This is G is G value is given as 2.65 minus 1 into diameter we have it as 0.025. So VD value will be coming as 6.56 centimeters per second. So this is the required value for the scoring velocity. Previously we got the flow velocity, that is V is equal to 1.35 centimeters per second. See, this value is very much less when we compare to the scoring velocity. If it was exceeding this value, that is 6.56, we should have redesigned the velocity, or else we would have limited the velocity to 6.56. Now this is coming within the limit, hence this velocity, which is 1.35 centimeters per second, is okay. Okay, we can adopt this velocity as a flow velocity.